Welcome to Graphing and Simultaneous Equations, lesson number 4, Equations of a Line. In this video, we're going to have a look at how we can derive the equation of a line from a graph itself. So our learning objectives for this particular lesson is 1. How to graph a line from 2 points, and 2. How to extrapolate the equation of a line from a graph. So extrapolate meaning how can we pull data from a graph. Now the first learning objective we're going to look at is how to graph a line from 2 points. So consider we have 2 points and a Cartesian plane here, and we want to draw a line that runs through points -3, 1. So x equals -3, y equals 1, and 0.67. So x equals 7, x equals 6, and x equals 7. Well, we're going to do this using 3 steps. The first step is we're going to mark the 2 points on the Cartesian plane. So looking at -3 and 1, I'm going to find -3 on the x-axis. So it is going to be 1, or -1, -2, -3. Then I got to go up 1 to here. So I'm going to mark that as such, and I'll label it -3 and 1. Now the next point is 6 and 7. So I'm going to count 6 across on the x-axis. 1, 2, 3, 4, 5, 6. Then I'm going to go up 7. 1, 2, 3, 4, 5, 6, 6, 7. And I'm going to mark that on the plane as well. So what we get is 6 and 7. Excellent. Now the next point is we have to draw a line that goes through both points. So to do that, get my ruler out and I'll spin it around. So I have to use my ruler, otherwise I'm going to draw a really messy graph. So there we go, it seems to be going through both points there. And now I'm going to draw a line going through both of those points. So I'll get a nice thick pen so it's easily visible. And rather than stopping at the point, I'm going to get the line to pass through both of them and continue onwards. Putting my ruler back in my pencil case, I'm going to finish that off by putting the arrowheads on the line. So the arrowheads are really important because they denote that the line goes all the way from -infinity to +infinity. If I don't have the arrowheads and I've just got a plain line, I don't actually have a line. What I've got is called a line segment. So it's only a snippet of the line. It doesn't go to negative and positive infinity. It just goes to where it's been drawn to. Now the final step of graphing a line from 2 points is I need to annotate it. And the way in which I'm going to do that is I'm going to write the equation. Now notice we don't know the equation to this line yet, do we? So we can't really graph a line from 2 points just yet. So this is going to follow on into our second learning objective, which is how to extrapolate the equation from a line, or of a line from a graph. So consider the line we just drew, and it passes through points -3 and 1, and 6 and 7. We want to derive or extrapolate the equation from this particular line. Now the way in which we're going to do that is we have to get all of the features, or identify all of the features on the graph. So the y-intercept, the x-intercept, the gradient, all of those. If we can get all of those pieces of information, we can actually derive the equation from the line. So the first one I'm going to look at is the y-intercept. So recall the y-intercept is the location where the line crosses the y-axis. And looking at this one, it crosses just there. So this point here, if you look really carefully, it crosses at 0, so x equals 0, and 2.5. So positive 3 is there, and this line crosses midway between 2 and 3, so it's 2.5. And now our gradient, if I pick 2 points of the line, and we do the rise over the run, so I'll pick this point here because it touches the grid exactly. Let's keep going across, and could go up here, but I'll keep going, and we'll do this one here. So it looks nice and easy to measure. So we've gone across 1, 2, 3, 4, 5, 6. So we've got a run of 6, and we've got a rise of 1, 2, 3. And remember, our gradient is m equals rise over the run, and if we've got a rise of 3 and a run of 6, then that simplifies down to m equals 1 over 2, or 0.5. Now notice that we've got our y-intercept of 0 and 2.5 and our gradient of m equals 0.5. We can write or substitute this m and this c into the formula y equals mx plus c. Now what I didn't mention was our y-intercept here. Recall that the c value is that value there, so the y coordinate in the ordered pair here of the y-intercept. So c is going to be 2.5, so I should have wrote that earlier. Now to get the equation, we substitute in m and c, so y equals mx plus c, and we discovered that m is equal to 0.5, so 0.5x plus 2.5. So what we've got over here is our equation for this line. Now to completely finish everything from before, what we're going to do is we'll go back to our original line we drew, and we'll finish annotating it, and it is y equals 2.5x plus, 0.5 I mean, 0.5x plus 2.5. So let me just double check that I didn't forget between here and there. Yeah, 0.5x plus 2.5 and 0.5x plus 2.5. So that is how we'd graph, or that is how we graph from 2 points on the line, and that is how we extrapolate the equation of a line by looking at the features. Now let's do 2 more examples, and we'll make them slightly different. So we're still on how to extrapolate the equation of a line from a graph, but rather than having 2 points, what if we've got something slightly different? We have something slightly different. What if we want to graph a line, or what if we want to find the equation of a line that runs through point -5, 0 and has a gradient of m equals 0.2? Now we could simply do it all algebraically, and we can substitute in the point is -5 and 0 into the equation here, and m into the equation, and then figure out the value of c, or we can graph it and then extrapolate the data from there. So the first thing I'm going to do is graph this particular one. So what I need to do is I need to plot -5 and 0 on the Cartesian plane over here, which I've already gone and done, and then I have to do the gradient of m equals 0.2. So remember, the gradient is the rise over the run. So here we go. Whoops, it's a bit thick. Here we go. M equals 0.2, and we want to have that as a fraction, so m equals 0.2 over 1, And I'm going to ask myself, what do I need to multiply 0.2 by to get it into an integer? And the value for that is going to be, let's say 5. So 0.2 times 5 is 1 over 5 equals, let's say 1 over 5. So our rise over the run is 1 over 5, so therefore, for every 1 we go up, we're going to go across 5. So starting at this point here, I'll do that in purple. For every 1 we go up, so go up 1, we have to go across 5. So this will be 1, 2, 3, 4, and 5. So I'll label that, and I'm going to annotate it because this is 0.01. Then I'll get my ruler out, and I'm going to draw a line between these. And there we go. Perfect. Now I'm going to put the arrowheads on the line like such. Now looking at this particular line, I can already see that we've already put our y-intercept there, and therefore the c value is going to be 1, and we're already told that it's got a gradient of 0.2. So what we can do to substitute the values into the formula is we can say y equals mx plus c. Our c value is this guy here. Our m value is this guy here. So we can simply write 0.2 x plus 1. So the equation for this line, when I annotate it, is simply going to be, and I'll annotate it in purple, y equals 0.2x plus 1. So the equation for this particular line here is 0.2x plus 1, and the original question was state the equation of a line that passes through point -5 and 0 and has a gradient of m equals 0.2. So the equation here, and remembering what we did was we set our gradient, we turned it into a fraction, so it was easy to count the steps and go across, and we plotted the point and simply drew a line that went through both of these 2 points here. Now consider a different example, and that is the equation of a line. So we want to find the equation of a line that passes through point 2, 3 and intersects the y-axis at y equals -2. So once again, what I'll do is I'll find 2, 3. So I'll find this ordered pair 2, 3 on the Cartesian plane. So 2 on the x-axis is here, 3 on the y-axis is up here. So marking the point, it's going to be 2, 3. And the y-axis, it intersects the y-axis as y equals -2. So y equals -2. Because it's the x or the y-intercept, because it's the y-intercept, we always know when the y-intercept always happens at x equals 0. So putting these two pieces of information together, we can see that the y-intercept is at 0 and -2. So what I can do is I know that the line passes through 0 and -2. So 0 and -2 right there. Now grabbing my ruler, so that looks like a nice color. So doing it in blue like so. Putting the ruler back in my drawer, putting the arrowheads on the line, a little bit thick, but that's alright. Then reducing the thickness of the pen. So what we need to do is we have to figure out what the gradient is here. Now remember, we've got the rise over the run, so I know this line passes through point 0 and -2, and 2 and 3, I'm going to count the steps between these 2 points. So going across, I'm going to go 1, 2, and then going up, I'm going to go 1, 2, 3, 4, 5. So 2. So we've got a run of 2 and a rise of 5. So therefore our gradient is going to be a rise over run, which is going to be 5 over 2. And notice that this isn't going to, actually it will be, getting down to a decimal. 5 divided by 2 is 2.5. So our gradient is going to be m equals 2.5. Our y-intercept is at -2. So substituting all of these into the equation, we're going to get y equals 2.5x plus -2. And we don't need that plus there because there's a negative there. So it is simply going to be y equals 2.5x minus 2. Now to complete the drawing, because that is what we like to do, have complete graphs. Further down, y equals 2.5x minus 2. There we go, that's neater. So in this example here, we had a look at how to get the equation or extrapolate the equation from a line that passes through point 23 and intersects the y-axis at -2. Now in the next lesson, we'll have a look at how we can get this equation without actually having to draw the graph. But for today, we will use this method here. So in retrospect, or in conclusion, looking at our success criteria, what we learned today was we learned that we can graph, or how to graph a line from 2 points, and then we learned how to extrapolate the equation from a line from a graph, or extrapolate the equation of a line from a graph.